Hey guys, welcome back to another video. It's been a while since I did my last one just because I was preparing for an exam and I was out of the country for a while, so I'm really sorry about that. I know there's like a few more days till the AP exam, so I thought I'd make a little series just working through free responses and practice multiple choice questions from the AP exam. So obviously I'm going to start with the free response. Now the thing with the free response is it's a pretty big time crunch, right? So you have 7 questions total, 90 minutes. So you have like a little less than 13 minutes per question. So it's definitely students are definitely kind of scared about that, and I was too when I took it last year. But after reviewing it and taking it, I realized that there are a lot of sort of limitations they have to place on the exam because of this time constraint, and it could work to your advantage. So I'm going to go over sort of just like a few broad things about the free response, and then I'm going to go over a certain question, and I'm going to keep going through questions throughout the week. So some like really like broad like things about the free response, right? So 13 minutes or like less than 13 minutes per question. Now, what this tells us is each sort of question out of the 7, so 7 questions, right? So each topic is covered in a question, right? So it could be over like structure, right? IMFs, kinetics, acid base, equilibrium. There usually isn't anything about organic chemistry. There might be like a few like small little things here and there, but it's not big. And there are a few more. So what you have to realize is each question will focus on a certain topic. And they won't stray that far away from this topic. So whenever I see a question, like let's say like, kinetics, or like let's say like acid base, like the one we're going to do now, they're only going to have a few things in that sort of question. So you can already kind of predict what they're going to do. Like if it's acid bases, for instance, right? Then you can expect something about titrations, everything in titrations, like half equivalence, equivalence, and then, percent ionization, ice tables, just knowing how to calculate the pH of like different things. And they kind of just like make it just about acid bases, and very rarely do they add anything else, aside from like stoichiometry, which kind of branches to everything. So once you see a topic in a question, just like remember all sort of the topics that they'll have, and then you should be fine in the time constraints. So I'm going to go over a question from 2014. It's an acid base, right? So we already kind of know what it could potentially be. So that way you can sort of just like be able to do it. The only like the big sort of advice I'd give you is not to get too caught up in a certain part of a question, and just like skip it and continue on, because the best thing you can get out of just like staying in that one question is just that question, right? If you keep going and you're able to get what you can in the rest, you get way more points, and the curve should be able to take care of you after that. So I'm gonna have question 2 of 2014 linked below. And I'm gonna just sort of go over my thought processes and of how to like work through this. So part A. So part A asks, identify a Bronsted-Lowry conjugate acid-base pair in the reaction. And the reaction given is propanoic acid. It's a carboxylic acid reacting with water. So this is just like the Ka expression. So when I look at this, I already know that this is a Ka reaction, right? So they're asking for Bronsted-Lowry conjugate acid-base pair. So immediately the pair I look at is this is the acid and this is the conjugate base. Obviously, this can also be a base and this can also be a conjugate acid. You can use both pairs, but this is the one that sort of is immediate to me. Second question, or part B, says determine the value of Ka. So based on the description that they give already as a part of the question, it says a 50 ml sample of 0.20 molarity propanoic acid. And they say determine, and that gives you a pH of 2.79. So this is actually not a very traditional question, because normally what they do, they're asking for Ka, right? Normally what they do is they give you the Ka and the milliliters and molarity, and they ask for the pH. So here they're kind of telling you to work backwards. So the starting sort of position is still the same. Like, I would still do an ice table for this. So like here. So ice. So the way you can calculate the molarity of H plus and propanoate, this ion, because you know the concentrations of both of these are the same, and you can calculate them based on the relationship that the antilog of pH will give you the concentration, right? So this is nothing but you'll get an equilibrium concentration of just 10 to the negative 2.79 for both of them, right? And then they give you a 0.2 molarity. So basically, then you use its equilibrium, and you multiply these and divide it by 0.2, right, because of the equilibrium, and you get an overall Ka. Let me calculate that really quick. Almost there. And you get 1.3 times 10 to the negative 5. So you get 1.3 times 10 to the negative 5. All right. Actually, let me just do this. All right. The next one they ask for is okay. Now part C, what they ask is, for each of the following statements, determine whether the statement is true or false. In each case, explain the reasoning that supports your answer. So for part C, number 1, they say the pH of a solution prepared by mixing 50 ml sample of 0.2 molarity propanoic acid with the 50 ml sample of 0.2 sodium hydroxide is 7. And they're asking if that's true or false. So what do we know, right? Like, let's look at all the numbers that we know. So they give you 50 mils of 0.2 molarity propanoic acid, right? And they give 50 mils of 0.2 molarity of NaOH. So this is a titration reaction, right? You have a titrant and the analyte, and basically you have the same number of moles of base and acid, and we know that from our definition, right? This is basically at the equivalence point. This is at the equivalence point, right? And it says that the pH at the equivalence point is 7, right? That's what this student says. But we know that sodium propanoate we know the pH of sodium propanoate is very basic. It has a pH greater than 7. So we know that this isn't the case, and therefore this is false. So 2, if the pH of a hydrochloric acid solution is the same as the pH of a propanoic acid solution, then the molar concentration of the hydrochloric acid solution must be less than the molar concentration of the propanoic acid solution. Okay, so that's a lot of words, but let's sort of get to the gist of it. Basically saying so they're saying to have the same pH, right? To have the same H plus concentration. This is from HCl, and this is from propanoic acid. This has to be, the concentration of this has to be less than the concentration of propanoic acid. And this is actually true because hydrochloric acid is a strong acid, and so it ionizes into H plus and Cl minus to a much greater degree than propanoic acid, which is a weak acid. So there has to be more propanoic acid, right, to have the same concentration of H plus, just because strong versus weak acid. So this is true. All right. So next one. As you can see, there are a lot of parts to this, but these can go by really fast. It just takes me a while to sort of explain things. So, okay, the next two parts are part of this sort of situation. A student is given the task of determining concentration of propanoic acid solution of unknown concentration. They use 0.173 molarity sodium hydroxide solution as the titrant, and they have a 25 milliliter volumetric pipette of propanoic acid. And it says that it takes 20.52 milliliters of the base solution to be added. Okay. So this is, again, just another titration reaction. And we have to use M1V1 equals M2V2. Okay, so you have 25 mils of propanoic acid, and you don't know the molarity, but you know the molarity and the volume of the sodium hydroxide. So you can divide 25 milliliters on both sides, and what you get is in fact 0.142 molarity. So fairly standard question. Right? The last part of this question. So they're asking, so this is actually a typical question. They ask you to redesign the experiment, right? So a student wants to redesign this experiment, and he wants to use butanoic acid, and it has a pKa of 4.83. And the student claims that a different indicator will be required to determine the equivalence point of the titration accurately. Based on your response to part B, do you agree with the student's claim? So the indicator, right? There are multiple indicators. You know, you have starch, you have, you know, bromothymol blue, you have methyl red. You have all these indicators, and the indicators correlate to pH at the equivalence point, right? Around there. So if you have an equivalence point of a certain range, then and an indicator at that certain range, then you want to use that indicator. So indicators correlate to pH at equivalence point. So, and that pH of equivalence point corresponds to the pKa of the acid, of the titrant. So you know butanoic acid has a pKa of 4.83. Now, to know whether we want to change indicators is we have to compare this pKa point to propanoic acid's pKa. And we know that the pKa, we know the Ka actually, right? Because we know the Ka from our part B, we know our Ka is 1.3 times 10 to the negative 5, right? So to find the pKa of that is just log Ka, which is that, right? So we actually know this, and our answer for this is 4.89. 4.89 and 4.83 are really, really close to each other. So we wouldn't actually need to use another indicator. Now, let's say, you know, the side question to this is always like, how far is enough to change the indicator? And I'm telling you, if it's like 5 or like 3 or something, that's an order of magnitude of 10, right? 10 divided or multiplied. So anything within like 4, like in 4, like 4.2, 4.3, 4. Like anywhere around there, you don't need to change it. But if it's like 3 or 5, then you probably need to start thinking of changing your indicator because it's pretty far away. All right, that'll be all for this question. I'll probably see you tomorrow, and I'll be working on another question.